Okay, this is lesson 11, module 5. We're going to be working with volume, with fractional, edge lengths, and unit cubes. So the opening exercise is just to review volume, but it wants to know which prism, so the rectangular prism, holds more 1 inch by 1 inch by 1 inch cubes. How many more cubes does each prism hold? So if you remember the formula for volume, we always did length times width times height, but this year we're going to use it as an algebraic equation using variables only and no multiplication sign in between, so LWH, because we know that there is, when variables are close together, it is multiplication. So this is the length, this is the width, this is the height. We are multiplying it, length times width times height. 10 times 4 is 40, times 6 is 240 inches, and we're not squared anymore, we're working with cubic inches. It's three-dimensional. Now the volume of this rectangular prism, length, width, height. V equals LWH equals 8 times 5 times 12. I'm going to actually do, well, I could do either way. 40 times 12. You don't have to show every step, but I want to. Take away the 0. 4 times 12 is 48. And add the 0, 480 inches cubed. So which one holds more 1 inch cubes? So I would be able to pack more 1 inch. They're talking about a little cube if I wanted to pack things in. They're saying that 1 by 1 by 1, so I could pack, if I found the volume of this little one, which is 1 times 1 times 1 equals 1, if I divided it by 1, I would get 480, and if I divided this one by 1, I would get 240. So this one holds more cubes. So we're going to say holds more. Well, and they want to know how many more. So we're going to say 480 minus 240. 240. So holds 240 more cubes. Okay, the next one down here. It says a box with the same dimensions as the prism in the opening exercise is used to ship miniature dice whose side lengths have been cut in half. The dice are 1 inch by 1 inch by 1 inch cubes. How many dice of this size can fit into the box? So, in order to find this, the cubes, I'm going, and you probably should write this somewhere on your paper, possibly at the top. The volume of prism divided by the volume of cube, or prism divided by cube, and they're going to give me, they're both the same, how many cubes will fit. So I have this prism, it's the same as the opening exercise. So I know this prism is, the volume was 240 inches cubed. Now I have a cube that I want to pack in there. So I'll draw my cube. You don't have to if you don't want to. I just want to give you a visual. It's 1/2 by 1/2 by 1/2. So I have to find the volume of this. So to find the volume, I'm going to do cube volume is length times width times height. So 1/2 times 1/2 times 1/2 equals 1 times 1 times 1 is 1. Don't tell me 6 on the bottom, because sometimes sixth graders like to go 2, 4, 6. Nope. 2 times 2 is 4. Times 2 is 8. so it's 1/8 is the volume of the cube. So in order to find how many little cubes I can fit into this prism, I need to take, remember, the volume of the prism divided by the volume of the cube. So I'm going to write the volume of the prism divided by the volume of the cube. Now to make this whole number a fraction, I put a 1 under it. And when I have fractions in division, I'm going to keep, switch, flip. So it's going to look like 240 over 1, switch the sign, you can use the multiplication sign, over 8 over 1. And I'm going to multiply across. And 200, and you can use your calculator if you want, 240 times 8 is 1,920 over 1. So that would just equal 1,920 cubes. Okay, that's page S54. Make sure you have these examples down. Also, make sure you have this down somewhere on your page. It's a good reference for you to refer back to. Volume of the prism divided by the cube will give us how many cubes will fit in that prism. Stay tuned for part 2.